let's look at an example now where we actually have some restrictions in the original relation and we need to transfer those restrictions into the inverse relation. So we need to not only swap the x's and the y's in the formula, but we need to swap the restrictions as well. Then we need to rearrange not just the new formula so that it's in the form y equals something, we also need to rearrange the restrictions. Now that's the bit that people sometimes get confused with. So let's have a look at it in an example. Find the inverse relation of y equals 2x minus 3, where x is greater than 1. Now let's just work algebraically here. We can look at it graphically in a minute as well. But just making a direct swap with our x's and y's, we can say that x is going to equal 2y minus 3, and we know that y has to be greater than 1. So I've literally just changed the x's and the y's around. And perhaps on your working you might want to put that this is now the inverse relation. Okay, now I need to rearrange this so that y is the subject. So let's add 3 to both sides. And let's halve both sides. I'm going to write my y over this side, and I'm going to halve my x plus 3. So we've got another straight line now, and this is the reverse. Now, we could write where y is greater than 1, but the problem is, when you're looking at the restrictions, have a look at the original relation. It says y equals this, but then it gives the restriction based on what x has to be. So if we're writing what the new relation is, we really need to explain what the restriction is in terms of x, not in terms of y. How do we do that? Well, we've got an expression now for y. Y is equal to all of this. So if y needs to be greater than 1, all of this needs to be greater than 1 as well, doesn't it? So that's our next line. We can write out that half x plus 3 must be greater than 1. Doubling both sides, x plus 3 must be greater than 2. Subtracting 3 from both sides, x must be greater than minus 1. So that is now our restriction on our inverse relation, written in terms of x. And we need to write it in terms of x so that it goes with this. So now you could say, therefore, we have y equals half x plus 3, where x has to be greater than negative 1. All right, let's have a look at this graphically now and see if it matches up with what we've done algebraically. Can we graph this? Sure, it's a straight line with a y-intercept of minus 3 and a gradient of 2, so that's fairly steep. It's something like this, and it's going to go through here at 1.5. Okay, so if we were to graph the inverse of this, let's just draw in, oh, it's not a great drawing, is it? Let's go again. Let's draw in the line y equals x. And now let's make our reflection. Our reflection is going to need to go through 1.5 on the y-axis. It's going to meet right there, and it's going to be a straight line like that. Now, does that look like the straight line we've come up with? Well, it's got a gradient of half. Yep, that looks right. And it's going to have a y-intercept of half times 3, which is 1.5. Yep, that's exactly what we've got there. So doing it graphically or algebraically, we're going to get the same thing. But what about the restriction? Well, this one has a restriction where x has to be greater than 1. So in other words, we're actually only interested in our original function from x being 1, which is about here, onwards. So all of this part doesn't actually exist. It only starts from sort of here upwards. So that means that on our, if we just looked graphically, we would say that the restriction here is around the same way. And that means that instead of x having to be 1 or more, y would have to be 1 or more. So that means it would start around about here where y equals 1, and we wouldn't have any of that. And that matches up. You can see the symmetry there, that it looks right. So if you're more of a artistic person and want to work graphically, you can do all these things graphically and then come up with the formulas. If you want to work algebraically, you can do the same thing. Even better, you can do both and check that your understanding matches up both ways.